How did Tycho Brahe observe the cosmos? Imagine trying to measure the night sky with tools so precise that they could detect tiny changes in the position of stars and planets. That's exactly what Tycho Brahe did. Before telescopes existed, he relied on large, carefully built instruments to study the heavens. His goal was to gather data so accurate that it could challenge old ideas about the universe. Tycho designed and made some of the biggest and most precise instruments of his time. He built giant sextants and quadrants, some over 5 feet long, which allowed him to measure angles between celestial objects very accurately. He also created an armillary sphere, a model of the sky, to help him understand the positions of stars and planets. These instruments were mounted on stable bases and adjusted with fine screws and brass plumb lines, reducing errors in measurement. He used these tools to take repeated measurements of the positions of stars and planets. Every night, he recorded where objects appeared relative to fixed stars. His notes were detailed and systematic, covering over 1,000 stars and thousands of planetary positions. This was much more precise than what earlier astronomers could do. One of his most famous observations was of a bright new star in the constellation Cassiopeia in 1572. He tracked its position over time and proved it was in the distant universe, not in the sky's supposed unchanging sphere. This challenged the idea that the heavens never changed. In 1577, Tycho watched a bright comet pass through the sky. Using his instruments, he showed it moved beyond the moon's orbit, passing through the supposed planetary spheres. This proved that the heavens were not perfect and unchanging, as many believed. Tycho's careful data collection became the foundation for later astronomers, especially Johannes Kepler. Kepler used Tycho's measurements to develop his laws of planetary motion, which described how planets orbit the sun in elliptical paths. Tycho proposed a model where planets orbited the sun, but the sun and planets moved around the Earth. This was a middle ground between the old Ptolemaic system and the new heliocentric idea that the sun was at the center. In the context of European culture and ideas, Tycho's work was part of a big shift. His precise observations challenged the old views of the universe and helped set the stage for the Copernican Revolution. His methods showed that careful, systematic measurement could change how people understood the cosmos. His innovations in instrument design and data collection pushed European science forward and helped pave the way for the acceptance of the sun-centered model of the solar system.